Good afternoon, class. We are talking to our next section, our next chapter, chapter 10, is lines and segments that intersect circles. So we know a little bit about this. If you see some familiar definitions or familiar words, diameter is one, radius is one. You probably have hit those on in algebra or in 8th grade math. And then you might see that word tangent, which we talked about recently with trigonometry. So tangent does play an actual role, though we're not going to use it necessarily for finding trig functions. We will see its relationship in triangles in a circle. Note the right angle that is noted in this diagram. So for this one, you have an essential question: what are the definitions of lines and segments that intersect a circle? So in this case, I would have you work with a partner. And working with that partner, you are going to look up definitions for a chord, secant, tangent, radius, and diameter, which is at the bottom. But in the meantime, why don't we just create our own definitions? So let's just describe what we see. So we have a chord. So this is definitely a chord, and let's describe it. Is it a line or a line segment, as it says in our essential question? So in this case, it is a line segment. So line segment means it has endpoints. So line segments mean endpoints. And the endpoints are on the edge of a circle. So that's what I would put for a chord. So kind of just describe a little bit what you see. And so you have secant, which looks like very similar to a chord. However, the difference is it's a line. Lines mean they have arrows. Chords or segments have endpoints, and lines have arrows on the end. So the secant is a line. You can say that crosses a circle. But note the big difference between like secant and, for example, diameter, or secant and tangent, is tangent lays on the edge. So you can say it's a line. It is still a line. Okay, so it's a line that lays on edge of the circle, right? Pardon the handwriting. So it's a line that lays on edge of the circle. And note these are kind of like your own definitions that you're coming up with based on what you see. And so if we remember radius and diameter, radius, we know it was like half of the circle, and diameter was the full half, or the full circle, or goes across the entire circle. So with this one in particular, you have diameter, which cuts across the center, right? So you can say, no, I'm going backwards here. So diameter is a segment, because it has endpoints, cuts across center, right? From one edge to the other. Okay, and then we have radius, and if we remember our definition, or if we were trying to find the radius of a circle, if you learned it from previous years, pardon the noise, radius was usually like half the diameter. Okay, so you can say radius is half the diameter, if you remember that. Okay, so half the diameter. Okay, so that's just like some freebie freebie definitions to kind of know and get the concept of based on what you see. Now I'm going to give you the textbook definitions. So onto your next page, there is literally an entire page of definitions that you need to know. Some of them you know, and some of them that we're going to learn that are new. So we have basic definition like circle. Okay, so I'm going to zoom in a little bit. So we have our first definition, which is a circle. So a circle, or in a circle, or how to create a circle, is the set of all points in a plane that are equidistant from the center. Okay, so that means you would take any point, it's equidistant from the center, and equidistant, if you remember from last semester, equidistant sounds very similar to equal distance. So kind of keep that in mind as we talk about a circle. Now let's talk about a center. We already kind of know what the center is. The center is that point within the circle that's equidistant to the edge. So that is the center. So if we have a circle, if we created a circle, this little dot in the middle is the center. So now let's talk about radius. We kind of figured out what radius was, and that is the segment whose endpoints are the center and any point on a circle. So we kind of like drew a picture of this, but center to the edge, there you go, radius. Then let's talk about a chord. We kind of wrote down what the chord was, and the chord is a segment whose endpoints are on a circle. So note the chord kind of just connects from one endpoint to the other. It does not have to cross the center. So it's just the chord. And on to our next definition is diameter. So remember, diameter is where it does cut through the center. Give you some time to write. So let's go on to diameter. So diameter is a chord. So diameter and chords are very similar. But diameter is a chord that contains the center this time. So for example, like this. And I'll move it down so you can see the picture. Okay, so let's move on to secant. So we're talking about secant. Pardon me, I'm pulling out more markers. So secant is a line that intersect, as an S, a circle in 2 points. So think of it like a chord, but it continues on and on forever. So if I had this, definitely had to continue on there, and there's arrows on the end of it. Okay, so line that intersects a circle in 2 points. So intersect also means crosses. So our next one is tangent. The tangent is a line in the plane of a circle that intersect This is a line in a plane of a circle that intersects the circle in exactly 1 point. So if it lays right on the edge, for example, like this one does, that is a tangent line. Now that point, that exact 1 point, is called the point of tangency. Okay, so now let's talk about tangent circles. So tangent circles are coplanar circles. So coplanar, meaning they're on the same plane. So they lay on the same plane. So tangent circles are coplanar circles that intersect in 1 point. So let's say I had 2 circles. They're on the same plane, and they intersect at 1 point. Those are tangent circles. Okay, so concentric circles are also coplanar circles that have a common center. So think of 2 circles that are coplanar, but they share a center, bullseye. That's what I think of for concentric circles. Now, a common tangent is a line or segment that is tangent to 2 coplanar circles. And we'll see more visuals of these 3 on our next page. So, those are our full definitions for circle, center, radius, chord, diameter, secant, tangent, point of tangency, tangent circles, concentric circles, and a common tangent. So, now let's see some examples of these on our next page. So we have a segment whose endpoints are the center, and at any point in the circle is a radius. So these pretty much is another page of definitions, most of whom we've already written down. So if you have a highlighter, please feel free to highlight what is needed to be. So you may highlight your definitions, whatever seems best. So radius, so endpoints are the center, any point on it. Okay, and you have a chord, segment whose endpoints are on the circle. A diameter is a chord that contains the center. A lot of these we've written down, but it doesn't hurt to kind of understand your vocabulary. You have a secant line intersects a circle in 2 points. A tangent line is in a plane that intersects the circle at exactly 1 point, and that point is called the point of tangency. And this is where you get these examples from: chord, center, diameter, and radius, secant, point of tangency, and tangent. And so then we talk about coplanar circles and their common tangents. So in a plane, 2 circles can intersect in 2 points, 1 point or no points. Coplanar circles that intersect at 1 point are called tangent circles. And so these are called tangent circles because they share, there's a tangent line, so it lays on the edge of each circle, but they share a point of tangency. Okay? And then there's also the 2 points of intersection. We have coplanar circles that have a common center called concentric circles. So again, like a bullseye. But sometimes they don't have a point, 2 points of, no points of intersection. They don't intersect, but this one shares a point, while this one does not. So these are a few examples. And then our last one is the common tangent one. So common tangent a line or segment that is tangent to two coplanar circles. And a common tangent can have two things. It can be internal, which joins the center of the two circles, or it could be extra, which does not. Okay, and one way to look at that is if I were to have two circles, okay, and they touch here, that would be a point, that would be a tangent line here, and this would be internal because it's on the inside of its circle. So this would be internal. So this would be an internal tangent line. If I wanted external, this would be external. Okay? So the internal and then external. We will also see more of these in our examples. So let's go on to our next page for extra practice. And note, feel free to pause at any time you are stuck or need more time to write. Okay, so number 1, it says name to radii. So remember, radius, it starts from the center and goes out to any point on the edge of the circle. So, name two radii. Well, we have AB as a radius, I'm sorry. So we have AB, and note I'm putting line segment symbol on top. Note that I'm talking about a line symbol. AD could also be one. And even though it says to name two, we can always name three. And AF. The next one says to name a chord. Now remember, that's a line segment that goes from one side to the other, and it has endpoints. So an obvious one would be CE, because they have endpoints on them. But another one could be DF. It doesn't have to cross through center, but it's still considered a chord. Now the diameter, remember, is a chord that passes through center. So there can only be one, so it would be DF. Now name secant. Remember, secant is kind of like a chord, however there's arrows on the end, and only one of them fit that description, and that is line DE. Okay, then we have name a tangent. And tangent, remember, lays on the edge. So another way to think of this is if I were to play paintball, for example, and I almost had somebody, but I grazed the side of them and it went straight on through, that is kind of like what tangent is. So in this case, it would be the line through B. And your point in tangency is that point, point B. So that is 1 through 6 on naming some definitions in circles. So now let's go on to coplanar circles. So it says tell how many common tangents the circles have and draw them. So in this case, remember, tangents kind of lay on them, and then they have to share common tangents. So if we were to go back to our definitions for common tangents, so a common tangent, is a line or a segment that is tangent to two coplanar circles. Okay, so we're just going to draw some. And in this example, we have two, because if we were just to draw some on the edge and they have to share, I could only draw two. And I have 4 points of tangency. So 2. Number 8 says, tell whether each common tangent identified in 7 is internal or external. Well, remember, internals kind of deal with center. They're internally inside. However, are these two inside the circle? They're not. So these would be external. Okay, so that's 7 and 8. Moving on to number 9, I have to find BD. So to find BD, I have AD, which looks very much like the radius, and I have AB here, and last but not least, I have DB. Now notice in every little diagram that we have, anytime we have the radius and touch with the edge and we have a tangent line, I normally create a right angle. Again, this is kind of where that trick came along. We talked about right triangles and tangent. So this is kind of where they tie together with circles and triangles. So now, what kind of triangle do we have? We have a right triangle, and how would we find a missing side, in this case, BD? Well, we use the Pythagorean theorem. So then, all I have to do is plug in the Pythagorean theorem. So I have a squared plus b squared equals c squared. And let's just say BD is B, and that's what we're trying to find. So, if I'm looking for B, I know I'm going to need to subtract. So, I have B squared is equal to 5.5 squared. Oh, I guess a negative 5.5 because I am subtracting. Plus 10 squared. Or you can write this the other way. We have 10 squared minus 5.5 squared. In the end, you will have to square root. So 10 squared minus 5.5 squared. You can put this all in your calculator at once, but if not, please feel free to just write 100 minus whatever 5.5 squared is. But in the end, you'll have B, or in this case, BD, as 8.4, rounding to the nearest 10. Okay, so that's how right triangles can be involved with circles. And then as far as number 10 goes, we're going to skip that one for now. We're going to have more practice on these onto our next page. So that is all for 10.1. Your next page is a puzzle. You know how much I like puzzles. And it says, why did the scientist stay at the math teacher's house? And so you will have this one to complete, and I will take grades on. Thank you so much.